So, Unit 1, Lesson 1, Investigation 2. Yes, Crystal?
How long ago did you graduate?
What? What?
How long ago?
7 years ago. All right. So, Unit 1, Lesson 1, Investigation 2. Direct and inverse power functions. Okay. So, direct and inverse power functions. We did a little worksheet yesterday where you guys made some graphs, and you had to draw those graphs where you made like U's and S's and butterflies and volcanoes and all that fun stuff.
Yes,
All right. So, we did that yesterday. So, yesterday there was a general form of a function that you used on your paper. All right? Actually, there were two general forms. One was y equals kx to the n. The other one was y equals k times k over x to the n. Right? These are the two forms. Right? Which one is inverse? Which one's inverse? Left or right? Kane? The right side's inverse. Good. Which makes the left one what, Kevin? Direct. Good. Now, on your paper, what I would do is I would label the inverse and direct side. I would write across the top inverse or across the top direct, so that way you know. All right? Write it across the page, inverse or direct, so that way you know when you're looking at it quick. All right? Does that make sense, guys? You got a question, Ricky? No. Okay. So, in these power functions, what is the n?
Negative.
Nope.
You gotta write that?
It's your notes. You can write it whatever you want. Okay. What is the power? What is the n in the power functions?
Negative.
Nope, it's not negative. What is the n? It's the exponent. Good. The n is the exponent. Now, Kevin, I'm using a script n. Okay, not a normal n. Right? It's the exponent. We also call it a power. Now, I'm using that script n to remind you that this is a number. Okay? Because if n is not a number, if n is a variable, this is no longer a direct function. It then turns into an exponential function. Okay?
So, if the n is down there where the x is, it's not an exponent?
No, this is still an exponent. It's
I
just
mean,
it's just
it's
the
not-
x. Oh, like where the k's at?
No. Can you repeat what you said before?
About this? Okay, n is an exponent. It's a power on the x. Okay? It is just a number, like 1, 5, 7, pi, 3, 2, whatever it is. It's just a number. Okay? If n were not a number, if n were a variable, then this would be an exponential function.
So then that one's exponential.
No, these are both power functions because the n is a number. Okay? The n is one number for the whole time. So it's like y equals 3x squared, so the n is 2. Okay, yeah, I'll do it right there. Okay. So like y equals 3x squared. Okay? The n is 2. It's a number. Alright, does that make sense? Yeah. Alright, is that cleared up or no? Yeah? Okay. Alright, so n is an exponent. What's k? Constant, right? K is the constant of proportionality. Right? And this is also a number. Right? What are x and y? What's x, Richie? Or Ricky? Richie is in 6th hour. Ricky, what's x? What is x? The special variable. What variable is it? Independent. Good. And y is the dependent. Does that make sense? No?
Yes.
Yeah. So it's just like what we did when we talked about inverse and direct earlier, except now I've just added that exponent n. So it's the same exact thing, except now I've added the exponent n. Now, can I write these equations in a different way?
Yes.
Yeah, how, Chris? Start with direct. How can I write direct in a different way?
K equals y over x.
K equals y over x to the n, right? Okay. How can I write the inverse one? K equals what?
Y.
Good, yx to the n. Okay. So those are the alternate way to write it, the equivalent ways of writing the equations.
Oh, I thought like when two numbers are by each other, they were both direct, but direct couldn't be divided.
Direct can be divided. Okay. So what you got to think of, Ariane? So Ariane said that if two numbers are by each other, meaning they're being multiplied, that it's got to be direct. That direct can't be divided. Okay. That's only true when we're solved for y. Okay. See how I solve for y here? Y is by itself. Down here, what do I solve for? K. When you're solved for k, direct is division. When you're solved for your constant, direct is division. Okay. Does that make sense?
Yeah.
Okay, we'll do some examples here in a second with that. Okay. Any other questions? Crystal? No? You sure? All right. Trying to be YouTube famous, huh?
No,
Just giving you a time. Okay. Here I have some power functions, right? Some different power functions. Okay. I want you to classify them as direct or inverse. Okay. So classify these as direct or inverse real quick. Okay. You don't need to do it on your paper if you don't want to. You can just think. Okay. So what's this one?
Direct.
Direct. Okay. What about this one?
Inverse.
Inverse. Why'd you say inverse, Sean?
I said it before everybody else said it.
Why'd you say inverse? Jordan, why do you say inverse?
Because it has both an exponent and division.
Okay.
It almost completely follows the inverse pattern.
Udo, go sit back over behind Yanni. Okay? Okay. So, Jordan, he said it's inverse because it has a power and it has division. Right?
Yeah.
If it has division, does that make it inverse?
Yeah.
No. It's the location of the x. Okay? This x is on top, isn't it?
Yeah.
I solve for y. This is like writing 1/2 times x to the third. Okay? Is that direct or inverse? It's direct.
So if the x is on top, then it's direct.
If we solve for y, meaning y is by itself, if the x is on top, it's direct. Okay? If we solve for y, okay? Every single one of these are solved for y. Okay? Because y is by itself. Okay?
So what if y has something?
We'll get there in a second. Okay? Alright, how about this one? Direct or inverse? Inverse. Okay? It's inverse because where's our x?
At the bottom.
On the bottom. What about this one?
Inverse.
Inverse.
Same thing.
Okay, same thing, x on the bottom.
X on top.
Now let's rewrite some of these. Okay, so those ones are the other form, right? Am I solved for y or solved for k?
Okay.
Solved for k. Right? These are all solved for k. K is by itself, correct? These are my constants.
Yeah.
Right? So is this one direct or inverse?
Direct.
Direct.
Y's on top.
Okay. Well, y is always on top.
Well, I mean.
Okay. This one is direct because my x is where? On the bottom. Okay? And I've solved for
K.
K. Alright? So this one's direct. What's this one?
Direct.
Direct. Still direct. What about this one?
Inverse.
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 Now, this one is inverse because I'm solved for K and X is on the top. Okay? And this one's also inverse.
I like this one better than the other one.
Yeah? It's the same thing.
No, but it's like the way it's rolled out looks better.
Okay, because if I do this, David, it's exactly what we've been doing, isn't it? So all the things we're talking about right now apply to what we learned last week as well. Does that make sense?
Yes.
Yeah? No? Now it doesn't make sense? I erased the powers, it no longer makes sense? Alright. Are there any questions? I need to erase these to make space. Okay, Dimitri. You have a question, you're just copying. Just copy now? Okay. Crystal, what's the question?
Okay, how come you said that, you know how you said that now it's confusing because it doesn't have the power thingies?
No, it was, David said it made better sense with the powers. So when I took the powers off, I asked if it was still
It was a
confusing.
joke.
Yeah, he said it was, but he was just joking. Is it confusing for you?
You should put them back
Yeah,
on.
okay.
Well, now that you said that, yeah.
Okay, so now that I have no powers, right? It's the same thing as if I had the powers. Okay? Because it's just like if I have no power, it's essentially I have a power of 1. Okay? So it's the same rules still apply. Alright, I guess I'm guessing what part is confusing?
So what matter is the x wasn't located.
Where the x is compared to what we're solved for. So we're solved for y. If x is on top, that means it's direct. Because if these x increase, the y will increase. Okay? In this one, we're solved for y, and the x is on the bottom, right? So if x goes up, y will go down. Because if x is 1, it's 1/2, right?
For what? For direct?
For inverse. If x goes up, y goes down. Okay? And now these ones, okay? If I'm going to keep 3 constant, if y increases, x has to increase. Okay?
Yeah.
So what happens if it's like y to the second?
If it's y to the second, that's fine. Okay? Still the same thing. For this one, if I'm going to keep 1/2 constant, if y increases, x will have to decrease. And that's why it's inverse. Is that helping, Crystal? Kinda? Okay. Alright, now, yesterday we focused on the graphs. Dimitri, you all set?
Yeah.
Okay. Yesterday we focused on the graphs, right? You guys have your graphing paper. I want you to flip to the direct side. Hopefully you wrote direct on the correct side. Okay. The side that has lines and U's and S's, that's your direct side. There you go. Okay. So the side that has lines and U's and S's, that's your direct side. Okay. Now, what's one thing we know about every single direct graph?
Direct. They touch the x, the y.
Where the x and the y overlap, right? What's that called? The origin, right? Every single direct graph will pass through the origin. Okay, and the origin is 0, 0. Okay? Every single direct graph will pass through the origin. Okay. Every single direct graph passes through the origin. Okay. Anything else we know? Anything else we know? I'll give you some hints. Okay? Look at your specific n values. Okay? When they're 1, when they're even, and when they're odd. When they're 1, when they're even, when they're odd. So there's our hint. Okay? Now this might be similar to something we did yesterday, right? So when n equals 1, what do we get? When n is 1, what do we get? We got a line, right? When n is 1, we'll always get a line. So if I just have y equals kx, n is 1, we'll get a line. Right? What about when n is odd? Nope.
You get a line going the other way.
We get that s thing, right?
Yes.
Okay? And when n is even, we get a u. What's the name? What's the real name for the u?
Umbrella.
Parabola, not an umbrella.
Parabola.
Okay. It's a parabola. Okay. So the line looks like this. Right?
Yeah.
Bless you.
That's your thing.
The S, where does the S start? Bottom left, top left, bottom right, top right. Where does it start?
Wherever it wants to.
No, it doesn't start where it wants to.
Bottom left.
Bottom left, and where does it end?
And
Right.
Top right.
Top right.
So it looks like that, correct?
Yeah.
Yes.
why does it always start at the bottom?
Well, it doesn't always start at the bottom. There's a way I can make it start at the top.
Start at the top.
But we'll get there in a bit. Okay. And the parabola, which you guys like to call the U,
Umbrella.
I call it parabola.
well, that's not an umbrella right there. That is a cereal bowl. Okay. We'll get an umbrella later. Okay. Are there any questions? Any questions? No? Okay. So, is the n value the only thing that changes these graphs? What else change it?
Okay.
The k value. Okay. The k value also changes. Now the k is our constant, right? Our constant, it's a number. What does the k do?
Never changes.
It never changes, okay. What does it do to our graph? If I change my k for, like, let's say look at all my line graphs, right? If I change my k, what happens to the lines?
It gets steeper.
Okay, it gets steeper, right?
Yeah.
Or it
Is
gets
that for large or for small k's for steeper?
So large.
Okay. Large k's make steeper graphs, right? Okay. And small graphs make less steep graphs. Now, if I have a line and my graph is steeper, right? It points up more, doesn't it? If I have a parabola and my graph is steeper, what happens to it? Does it get more narrow or more wide? So I have a parabola and it gets more steep. Does it get more narrow or more wide?
narrow.
It's more narrow. Okay? Thank you. So large graphs, or large Ks, make narrow graphs. Right? We have. Small Ks make
Wider.
wider graphs. Right?
Negative.
Yes, David, this is basically the summary of what we did in our activity the other day, isn't it? Okay? But it's always good to go over things a couple times. Completely up to you there, your notes. If you are confident that you'll never lose that worksheet, and you like how it's written on the worksheet, then you're fine. Okay? Alright. Now, negative K. What does the negative K do?
Flaps changes the graph to the opposite of what it looks like.
Okay, so you change the graph the other way, right? So we could say it flips the graph. Does that make sense? Okay. So, I'm going to draw these graphs again, but now I'm going to draw them with the negative K. So this blue line is the positive K, right?
Yeah.
I'm going to come back with a green line. I'm going to draw a negative K value. What happens to this graph? Instead of going this way, how does it change?
Oh, that way.
It goes this way, right? It goes down like that. Okay.
This
Not, I know not all of you guys have multiple colors, so what you can do instead of drawing a different color is you can dash this line.
Make it darker.
Okay?
Yeah, make it.
Or make it darker. That'll work too. Okay. Just make a little note to yourself that the dashed lines are negative K and the solid lines are positive K, or the bold lines are negative K, right? What's this one look like?
It starts at the bottom right and goes up to
Okay, start the bottom right, goes up the top, or start the top left and goes
Yeah.
down to
the
bottom right. See, David, sometimes they start at the top. What about my parabola? Is it still a cereal bowl?
Now it's umbrella.
Now it's an umbrella. Right? You can dash these lines if you want to. Does that make sense, guys?
Yes.
Yeah. Are there any questions about direct graphs? Any questions about direct graphs? No? So our next graphs are going to be inverse graphs. So we can get it all in the shot. Nope.
Yeah.
So, inverse graphs. Now, what do I know about inverse graphs? What's one thing that's true about every single inverse graph? Every single inverse graph. What's one true thing?
It's never a straight line.
It's never a straight line. I think there's something else.
It's always inverted.
Okay, it doesn't go through the origin, but more specifically, it never does what?
Touches the wire.
Touches the y or x-axis, right? So inverse will never touch the y or x-axis. So if you have a graph that never touches the y or x-axis, then it's probably inverse. Will never touch the y or x-axis. Now, are there any special cases?
No.
There's no special cases? So they all look exactly the same?
No.
Yeah.
No, they don't.
They do.
Okay, we get 2 types. What are the 2 types we can get? The 2 types of inverse graphs, what are they? Butterflies or volcanoes. Good. Okay. How do I get a butterfly? Okay. How do I get a butterfly? My n is
Positive.
Nope.
Negative.
nope,
Positive.
nope,
Negative.
odd.
Ah.
Okay. If my n is odd, then we get a butterfly.
Odd is even. Odd is negative.
If n is even, we get
The volcano.
volcanoes.
Isn't the volcano the same thing as the parabola?
No.
Yeah.
How's it different?
Same power. Right? They're either always positive or always negative, but they're a little bit different.
Don't they look the same?
You just like saying parabola, don't you, David?
No, I'm saying don't they look the same?
No.
They're both of you, aren't they?
I don't think. Is there any at the end of volcano? Sure.
Yeah, yesterday you spelled it wrong.
That's like volcano.
No.
No.
The sign
You just
Yeah,
spelled
it's
it
not
wrong.
seven.
That's
All right.
Volcano.
All right. So when n is odd, we get a butterfly. What does a butterfly look like?
Same with wings.
Is the curve on top on the right or on the left?
On
On the right.
On the right.
So it looks like this,
Bottom right.
like that. So there's my butterfly, right? And my volcano. Right? Volcano, the curves are where?
Up left.
Top left and top right, right? So here's my volcano. Okay. Does that make sense? That make sense? Okay. So remember, those are for a positive, right? And we'll come back here in a moment with the green one and make negative volcanoes and negative butterflies. Okay. All right.
Right.
Now, how does K affect it, Dave?
I was gonna ask the AC.
It is on.
It is?
Yeah.
Why is it terrible?
I don't know.
The window's open.
I know, it's good for 3 days. We must have used all the coolant in 3 days. Oh. We can hope for fall weather. All right. K value. What's the K value?
It's the thing that's constant.
K is our constant, right? How does that affect the butterflies?
Because it never changes.
If it's, I don't know.
If I have a large K, what does that do to my butterfly? Does it make my butterfly bigger or smaller?
It's further from the y-axis.
Makes my butterfly further from the y-axis, right?
Yes.
So my butterfly is bigger, it is wider, right?
Yeah.
So large K's put us further from the y-axis, which makes the graph wider. Is that the same thing for volcanoes?
Yes.
Yeah.
Yeah.
Volcanoes. What does the small K do?
It makes it closer to the y-axis.
It's the closer to the y-axis. And that makes our graph more wide or more narrow?
Narrow.
Narrow. And what does a negative K do?
It flips the graph.
Flip the graph. David, was that you or was that Kevin? Come on, guys, pay attention, please. All right. David, pay attention, then.
That was Kevin.
All right. Hey, when you pay attention, everyone, good job. You guys can pick who's who. All right. All right. So, large will make the butterfly wider, or the volcano wider. Small K will make the butterfly smaller or narrower. Negatives flip. So that means my butterfly, instead of being below the axis on here, it'll be above the axis and below the axis over here. And my volcano is no longer a volcano, it's an underwater volcano, a crevice, or a sinkhole. Some people, I think 6th hour, call them tornadoes. Or is that this hour? I don't know. This hour, okay. Now, once again, if you don't have 2 colors like me, you can dash these lines. Are there any questions about direct versus inverse?
I like direct better.
Like direct better?
Yeah, like my, it's right?
So we have preferences. The direct ones look cuter.
Yeah, look at that. That's cute. than this one.
Well, that one's got butterflies in it.
They don't look like butterflies. They
All right.
look really messed
Come
up.
on.
One thing I want to point out to you guys. For direct, large K makes them narrow, right? Small K makes them wide, right? For inverse, it's the opposite. Large K is wider, small K is narrow. Okay? So that's something important to make note of. Also, as I increase my n value, what happens to the graphs in both cases? They get what? Okay, the y's will get bigger faster, right? So the y's get bigger faster. What happens to the graphs? Do they become more narrow or more wide?
More narrow.
They become more narrow. So in either graph, if you have a bigger n value, the graph will be narrower. Okay, so either for direct or inverse, bigger n's make the graph more narrow. Right? Are there any questions? Crystal? No.
I mean, like,
That? Almost. Okay. Over here in black, we have y equals the square root of x and y equals 1 over the square root of x. So what I want you to do is I want you to graph those on your calculator, and I want you to determine if it's inverse or direct. Okay. So graph this one. So put y1 and y2. Square root of x, 1 over square root of x. I want you to graph it, and I want you to figure out if it's direct or inverse. Okay. Use your notes that you just took to figure out if it's direct or inverse.